so here we want to find a formula for a function that has vertical asymptotes x equals 1 and x equals 3 and a horizontal asymptote at y is equal to 1. So basically what it's saying is that if we have the horizontal asymptotes of x equals 1 and x equals 3, that means that we should have x minus 1 in our denominator and then x minus 3. Okay, and so now we need to figure out what does this numerator going to give us. So let's just call this a, since we don't know what that is yet, because we want to make sure that the horizontal asymptote is going to be y equals 1. Now let's take a look at what happens when we distribute and multiply x minus 1 times x minus 3. We end up getting x squared minus 4x plus 3. So our goal is if we wanted to take the limit of this function. Okay, so if we wanted to take this limit as x is approaching infinity of this function a over x squared minus 4x plus 3. Well, our goal is to divide the numerator and the denominator by the highest power of what's in the denominator. So when we want to evaluate the limit of this function as x is approaching infinity, we're going to take the numerator a and divide that by x squared. We're going to take the denominator, each term is also going to be divided by x squared. So let's go ahead and put that in there. So we have x squared here, and then x squared. So let's go ahead and simplify that a little further. So if we want to get the limit as x is approaching infinity of a over x squared, and then we're going to divide that now, but x squared divided by x squared is 1, minus, we get 4x divided by x squared, which is 4 over x, and then we get plus 3 over x squared. So now when we evaluate this limit, we get a over infinity 1 minus 4 over infinity plus 3 over infinity. So we end up getting 0 over 1 minus 0 plus 0, which is equal to 0. Okay, so basically what this function tells us is that the horizontal asymptote will be at 0, but what we want to get is y is equal to 1. So can we change this value of a so that we can get 1 in the numerator? Well, what can we divide by x squared that's going to make it 1? Well, we can divide that by what? X squared. So let's check and see what that would look like. So if we said that the limit as x is approaching infinity, replace a to be x squared divided by x squared minus 4x plus 3, and let's follow the same steps. As the limit as x approaches infinity, we have x squared divided by x squared in the numerator, and then we have x squared divided by x squared minus 4x divided by x squared plus 3 divided by x squared. Okay, so now if we simplify, we get x squared divided by x squared, which is 1. In the denominator, we get 1 minus 4 over x plus 3 over x squared. And let me make sure that we put that limit in front of there. So as the limit as x is approaching infinity, and now let's go ahead. So when we apply the limit, we get 1 over 1 minus 4 over infinity plus 3 over infinity, which gives us 1 over 1 minus 0 plus 0, which gives us a value of 1, which is what we want to get. We want to get the horizontal asymptote to be y is equal to 1. So therefore, what we can say is we want to find a formula for a function that has the vertical asymptotes, which is x is equal to 1, x is equal to 3, and the horizontal asymptote at y is equal to 1. So we can let that function f of x be what we just found, x squared divided by x squared minus 4x plus 3.